manufacturing. So next one comes out with the electronic system manufacturing. So within the electronic system manufacturing, so what do we have a different types of test over there? Okay, the system consists of PCB that consists of a VLSI devices. As we know this basically, so if we have a PCBs that can be consist of an VLSI devices to be fabricated, right? So in this also, PCB fabrication is said to be as an bare board test. Okay, so when you are going to check on, when you are going to test any PCB fabrication process, that is said to be bare board test. So what we'll be doing in this PCB fabrication test in the sense? So you'll be checking within the PCB, each and every wire connection from each and every pin is correctly connected or not. That can be verified over there. Bare board test in the sense, each and every wire operation, wire connectivity between each and every lead or each and every pin section, it is connected clearly or not, that is going to be verified. Okay, bare board. So without placing any component, you are going to test the PCB. That's it. Okay. So PCB assembly. Next one comes out with a PCB assembly. So this is what assembly in the sense, after placing some components in the PCB, you are going to check the test. That is what it is said to be board test. Okay, board test. So see the difference, bare board test and board test. Okay, bare board test in the sense without any components. PCB assembly comes with placed components. It is treated as a board test. Okay, unit assembly in the sense each and every unit will be checked over there. So for example, if complete PCB design is done and every module is defined, so it will be treated as an unit assembly. Okay, unit assembly as a unit tester. System assembly. So after designing this n number of PCB modules and designed as an one system, one application, okay, that can be treated as an system assembly. In that, system test will be verified. Okay, system test operation can be defined over there. So in this PCB, sorry. Yeah. So in the PCB fabrications, fabrication similar to VLSI fabrication. As I said you on, PCB will be similar with the VLSI fabrication, etc. Same. And assembly steps also susceptible to defects. So testing performed to all the stages of manufacturing. So in the manufacturing, what happened? Each and every unit, each and every process will be verified, will be tested. And next concept will be coming out with the fault modeling. Okay, fault modeling. So up to now we have discussed what is the testing, what is the types of testing, and what were the application, what were the levels of testing within the VLSI domain. All we have discussed. Now we are going to start with fault modeling. Okay, fault modeling. So what is this fault modeling in the sense? For example, if we have any logic gate, for example, AND gate or NAND gate, whatever it may be. So if we treat any AND gate, okay, within that AND gate, if we have any faulty at the input of one input, for example, 2 input AND gate I have. So within the 2 input AND gate, if I have one faulty input, okay, faulty input in the sense, either the input is set to be stuck at 0 or stuck at 1. Okay, stuck at 0 or stuck at 1. So that can be treated as an faulty. Okay, so faulty in the sense we cannot justify correctly. That is what if the input is set to be stuck, that cannot be treated as an faulty. Why? Because it has to be verified. It has to be tested. After testing the input and the output of the outcome of the circuit, you will be getting you are going to justify either the operation is set to be failed or it's set to be passed. Okay, so faulty can be treated as in different ways. Okay, in several ways. So that's what we will be discussing in the faulty modeling. Okay, so in the faulty modeling, what happened? We'll be saying in 3 terms: defects, errors, and faults. Okay, so defects in the sense either that may be defects in the component manufacturing or circuit connectivity or a design of circuit operation. So in that level, we'll be defining some defects. Okay, and or within the component fabrication or development of the component. In that we will be having some defects that can be treated over there. Errors in the sense in the operational level. Okay, errors can be treated as an operational level. And faults in the sense either the device is set to be in an operating mode or an operating mode, that can be represented. So here we have a small representation. So with a small table. So typically printed PCB boards, we have with the some defects, okay, with their frequency of levels. So if we have a short operations in the short circuit operations in the PCBs, that can be taken as a frequency occurrence of 51%. Okay, 51% of fault modeling can be fault identification can be done over there. Okay, if the PCB within the PCB, if you have a short circuit operation, what happens? That can be defined as an 51%. Okay, open circuits can be treated as an 1%. Okay, open circuit defined in there, it can be treated as an 1% of frequency occurrence defects. Next one, missing components. If there is any missing of any components, some connectivity problem or missing of some resistors or diodes, whatever it may be. So if there is any missing of components, active or passive components, or that can be treated as an 6% of occurrence of the defect. Wrong components are placed within the PCB circuits in the sense that can be treated as an 13% of occurrence. Okay, reserved components. Reserved in the sense there is a generally what happens, each and every operational levels will be defining with some reserved components. Okay, so that occurs with 6% of defects. Next, bent leads. Okay, bent leads. So in the PCBs, what happens? Leads will be, if the leads are said to be bent, what happens? It is going to occur with 8%. 8% of failure, a frequency occurrence of defects. Wrong analog specifications. So if for each and every component we have analog specifications, right? So if there is any wrong analog specification, that can be treated as 5%. Defective digital logic. Okay. So if there is any logical operational defects, so that can be treated as 5%. Performance defects can be treated as 5%. Okay. So performance defects are there, and that is what it is of 5%. So totally, these are the PCB. Within the PCB, if we have a defect operations, that is what the occurrence of their frequency we have represented, percentage level. And here we come out with some definition. What is that defect? Okay, defect in an electronic system is a united difference between the implemented hardware and its intended design. So the defects within the electronic system can be represented with a differentiation within the hardware and the design operation itself. Okay, what were the defects in the sense? First one, process defect. Process defect is going to represent with missing contact windows, parasitic transistors, oxide breakdowns, etc. So within the process defect, what happened? We have a different level, different terms here within the VLSI chips. So one is of missing contact windows. Okay, if there is any connectivity problem within the each and every fabrication level or fabrication level or within the circuit level, that can be treated as a missing contact window. Parasitic transistors within the component level or oxide breakdown levels, so breakdown voltage or breakdown defining with their component level. Okay, that is what the process defects we say. Material defects in the sense, so we'll be saying bulk defects. Material defects will be treated as bulk defects in the sense cracks, that is what damage occurred, damage in the material, crystal imperfections, or surface impurities. Surface impurities in the sense within the type of material what we use within the devices, surface levels, that can be treated over there. Surface impurities, P type or N type or the P and N type, whatever the impurities what we use within the component design, that can be treated over there. Age defects. So that is what age defects in the sense dielectric breakdown or electro migration, etc. And package defects comes out with contact degradation and seal leaks. Okay, seal leaks in the sense if there is any leakage of some component level within the component level. So seal leaks can be treated on that. Package defects. Okay, seal leaks in the sense without placing that component, if it is opened or package itself opened or used or something. Okay, so that can be defined in the package defects. Okay, VLSI chips. So mostly defects occur either during the manufacturing or during the use of devices. The repeated occurrence of the same defects indicates the need of improvements in the manufacturing process or design of the devices. So mostly what happens, the defects will be occurred in the manufacturing level itself. Okay, that is what either the component is repeatedly used, or if it is packaged within the packages, or some damages, or some within the manufacturing itself we have some changes or improvements in the devices. All this can be comes under the defects occurred itself in the manufacturing. The next one comes out with the